Okay, guys, this is Cheese. Uh, I am upgrading my scooter, my Fieabor electric scooter, 5600 watts advertised, but it doesn't give you that true 5600 watts because it's way underpowered, as I said before in my previous videos. This is way underpowered because it's got tiny controllers. It comes with the factory, the tiny baby controllers to power the motors. This is 35 amp controller times 2. The main controller and the secondary bridged together to to run in dual motor. That's how these dual motor electric scooters work. This is the controller A, controller B. So when running in dual mode, you get combined 70 amp. Theoretically, you get 70 amp of power, but it's still way underpowered because each controller is only putting out 35 amp. There's very limitation. There's a limitation in power, your horsepower. It has very weak top end. I found out over testing, observations, um, trying different things, and based on my experience with scooters. This is my second scooter. I had a one before this that was much more powerful. It came with dual 50 amp controllers in this type platform of scooter. This is way slower because it's only 35 amp. So I was planning on upgrading it. I bought this because I knew what I was getting. I knew the scooter only has 35 amp controller. But Jesus is the one told me to get this particular one. That's why I simply obeyed him. I didn't go by my own ways. Because if I were to go my own ways, I would go with the scooter that has at least 50 amp, 45 amp or 50 amp for a 60 volt electric scooter. That'll give you plenty of power. I obeyed him, and now I'm here to I'm given opportunity to share with others on upgrading the electric scooter. Uh, because especially for those newcomers, new users, new riders who don't have experience, background in fixing, repairing, upgrading their electric scooters, this video is for you. Especially for those that need more power and for those that need to fix it if something broke inside, like your controller or the motor. Um, so I am upgrading it and I'm testing it and I have a good news. Uh, it's complicated. I'm gonna try to make it simple as I can. Uh, I don't want to just jump over to what I want to show because it would not make much sense. Okay. Um, by default, the electric scooters that you buy, uh, by default, the main, generally speaking, the main controller, the controller A, this one here, this is this is the one that handles most of things. It connects wires, your horn, tail lights, headlights, your throttle, your display throttle, your turn key switch. All those are connected to the main controller, and the controller B is secondary, which is a power assist. It sends power to the other motor, the front motor. By default, controller A powers the rear motor, not the front. and the controller B powers the front motor. They did that on purpose by design for safety reasons, because you don't want if you for when you ride your scooter, when you switch to run it in just a single motor, one motor, um, the rear motor will turn, not the front one. That'll give you more safe control. It will be safer for you because the weight tends to shift to the back when you accelerate. So you have a good grip and traction, and you have this handlebar to steer left and right. It's a great balance for control. But if you have a front motor running without and not the rear motor, then it will become unstable. Especially when you accelerate and turn at the same time, it will easily break traction and you will fall. It's much more dangerous. That's why they did that. That's why by default only the rear motor turns in single motor mode. In dual motor, you have a dual motors turning. So what I did is, because it's so underpowered, I rearranged the wiring. I disconnected the controller B simply by unplugging the battery cable. There are battery cables for each controller, okay, to power each one of them. This is the controller A battery cable connected. This one I just disconnected it. So what I did was I arranged it to have my controller A to send power to the front motor by rewiring. Oh, excuse me. So that I will have a slot available to put this in, to install this controller, this big controller. The 65 amp will power the rear motor. 35 amp controller will power the front motor. So that will be a rear wheel drive biased, like a sports car. 65% of power to the back and 35% to the front. It's a great way to do it. It'll give you better control, better balance. It will be much nicer. So that's why I did that. So I connected the controller, and I want to show you the good news. It is working. Here. This turnkey switch turns on the baby controller. Okay? And the display throttle is over here. It's flipped upside down. I had to do that so I can pull the throttle. Otherwise, I won't be able to do it if it's facing up. As you can see, power is on, and my powerful 65 amp controller is connected to this throttle display. They're all wired up under testing stage. Here's the key to turn it on. Although there's no light, no voltmeter showing up, but it is switched on. The power is switched on, and it will turn on. Look. See? It's also showing the voltage too, which is more accurate than this one here. 67.4 volt. And the dual motor is working. It's separately, independently They're not in a single loop system. This is a separate loop, two separated, independently controlled and powered electric scooter, front and rear motor. Here's the front. You see that? Here's the front. Here's the back. Rear wheel. See that? Dang, 53 miles per hour. By the way, that's tuned. I mean, that's calibrated, so it will give you more accurate speed. It's not a fantasy speed. It's more accurate. Probably off by about 2 miles per hour compared to the GPS. And here, see that? 51. Now watch. Dual motor. You see both wheels turning? Both wheels. Now here. Full thrust. 53. And the lights still work. The lights, headlights, tail lights, all those horn, all that stuff is connected to the baby motor, the baby controller, not this one. It is up to you. If you want, you can have it connected to this controller and not that one. But right now, this is the way I have set up. Headlights working. Tail light, turn signals, I'm not going to press horn because it's very loud. Brake light, both levers work. Both levers, when you press either one of them, brake light works. I had the wire connected, so now both levers work when you push brake. Brake light. Brake light. Yep, it's working. This is a good news. I'm very excited. I got two dual motor, independently powered scooter, one of a kind. I don't think many people out there have that setup. This is going to be good because you will have a better control. You can control the throttle independently. You can apply only needed power for the front to go and the rear. So under slippery road conditions, or when you are struggling for grip or control, you can, once you get used to it, you will have a better control because you can output only a certain amount of power sending to the rear motor and the front motor, which is a lot better. Which is neat. So yeah. I just gotta I'm waiting for the tool to come in. I need to drill the hole. I had trouble. I don't have the proper tools to drill it. I need the hole bigger, at least 1 inch or more, so I can run these wires through, these cables here. It will be mounted here. I will be drilling tiny little holes to run the screws, to tighten it with the screws, to mount this properly. I don't want to strap it with the those Velcro straps. See, this is pretty neat. Even though there's no light showing, it's switched on. It's simply working as a switch, on and off, on and off. Voltmeter, if I want voltmeter to work, I need to connect the wire to the battery's positive for it to work. This one here. This is the throttle display plug from my big controller, and this is the turnkey switch plug. You have to be very careful, especially when dealing with wiring. Especially when you are disconnecting battery wires, is the most dangerous ones here. This red and black, the positive and negative wires coming from the battery to the controller, you have to be extra careful, because if you don't, you could burn your hand. It will explode, ignite, spark on you. If you're talking high powered, controller and the battery, there will be a lot of current going through. When you disconnect the first time, it's gonna spark on you real bad. So you need to put your gloves on, wear proper safety gear, put your goggles on, put your body armor on, put your thick gloves so that you don't get electrocuted, because you don't want to be dead, do you? You don't want to die. So you gotta make sure to use safety gears, safety equipment to connect these wires. You'll need to. The rest of the wires are not dangerous. Like the phase wires here. The wires that the scooter need in order to turn the motor, there are the basics. First, obviously, you need the display throttle. You need display throttle plug connected. This wire, you gotta, when you work on the scooter, before you disconnect anything, you need to make sure to label all your wires as much as you can, all the connections. You need to label them like I did here. I used a rubber band with the pen to mark them, label them. It may seem complicated, overwhelming with wiring, but it's not really. Once you start tracing wires one at a time and label them, then it will start making sense, and it will not be as difficult. It will not be so complicated. It's really like common sense. These actually are not really that complicated. There are no special electronics or ECU that monitors your wiring. If there's any change to the wiring, the scooter would shut it down or things like that. It doesn't have those complex electronics. It's simply a wire connect, switch on, switch off. That's it. So it's actually pretty simple. Start tracing your wires. Like the main ones you need are throttle, display, wire connection. From here, you need the wires, trace wires for your turnkey switch. You need to trace wires for your light switch unit. This is very important because this unit has everything. It controls your headlight, turn signals, and horn. All these wires are connected, bundled together. through a cable housing. So it's got a lot of wires. So you need to make note of this. You need to label them, label this, label that. That's pretty much it. And the brake levers. There are wires connected to your brake levers for your brake lights to work, both left and right. So you gotta make note of that too. Here, this one, this is the baby controller. This one's coming from the baby. Okay, here, your throttle display wire. This is the one here. This, if you look here, it goes up all the way to there. This is the throttle wire, throttle display wire. It connects to this plug, and this comes out of, goes to your controller. This wire comes from your controller A. This is how the throttle display turns on, and you have a throttle control. And here's the turnkey switch. Simply trace them. This is a turnkey wire. This one here. This is a turnkey wire where it shows key. Connect to this plug. It's shared with your throttle display connector. Only one of the wires are interconnected to each other. And you have positive and negative to get power to switch on, to power your controller. So this, label them. You need to I wanted to show here important one. This is the one here. Light switch, light horn switch unit wire. This one here. This has a lot of wires. So you need to label them, all the plugs, each plugs, where they go to. Familiarize yourself with it. I'm not going to get into super details. This is just more of introduction to give you a feel of what it's like, and to cover the basics. But this here, this is the brake light wire. This is a brake light, your tail light, your brake light. When you press the brake lever, the light comes on. That's what this does. And also to turn on the tail light. That's why you have two sets of wires. One is for turning on the tail light by switching on from this unit for your night riding. And the other set of wires is to get signal for your brake light signal. So when you press brake lever, the light comes on. That's what it is. And they are connected to, see, if you trace the wires, it connects to your switch, your light horn switch unit wire. And also it connects to your controller A. I believe this is the I believe this is the low brake controller, low brake wire that sends signal to your tail light. Yep. And these are just extra connections, lights. because they are positive and negative. It simply is transferring, sharing, channeling out power for your lights, like your deck lights, things like that. Here's a brake light input. Yeah, right here. When you press, this is the brake lever here. This is the left, right brake lever wire. This is connected to your left brake lever or the right brake lever or both. There's a plug connection on here where if you connect both of them, you have both left and right brake lever connected. That's what this wires is. This connects to this plug here, brake light input. This also comes from your controller A. So you need to label them because there's more than one connection. It takes more than one connection to make your brake light work and tail light to work. For the motor to work, to turn, you need throttle display connected. You need phase wires, 3 phase wires, and Hall sensor wires. They are usually 5 to 6 wires. These, by default, they come with the motor. When you buy a motor, it comes with these wires. These 3 thick wires are base wires, base connector wires that powers your motor and also sends signal for your throttle level. So you have a throttle control. So when you press throttle all the way, it spins at maximum power. This is Hall sensor wires. It's like a computer wires. It monitors, it measures data, what's happening in the motor, things like your speed, odometer, calibrations, settings, things like that. So more commonly, this is required to be connected. There are some motors out there with the controller where it does not require Hall sensor wires to be connected, but most of them do. So these are the ones what you need in order for the motor to turn, for each motor. The front motor has the same thing, 3 phase wires, connectors, and Hall sensor wires, and the battery, and the battery wires. You need the battery wires connected to the battery from your motor. This is the Hall sensor. This is the phase connectors for the front that goes to the front motor. And the Hall sensor wires here for the front. And these are the headlights. If you upgrade your headlights or replace them, these are headlight wires, one for each, one for left, one for right. Left headlight, right headlight. They're individual. You connect them to your cable, your positive and negative. And this also connects to your light horn switch unit wire here. It connects to this one here. So this is very important. It connects to a lot of wires. Make note of all that, otherwise you won't be able to get your brake lights to work. You won't be able to turn on or turn off your headlights. Your horn wouldn't work. It's your call. It's up to you. You can also get, they also have a tail light, just like this one here. You can get this one instead. It's got auto sensing brake light. If brake light comes on automatically when you slow down, and the light stays on if you want it to stay on, which is good. I really like that one. You can use that. It's got the turn signal. It's got turn signal. Whatever. But this is the basics. So, yep. That's it for now. Once I get the tool, I'll put it all on, mount it, and then I will test it. Alright, guys. Okay, guys. Here's update. My electric scooter. The controller has been installed. Look at it. I drilled a hole big enough for the wires to run through. See that? It's nice and tight too. And I got the drilled holes for the screws. 4 screws are securing this controller. It's on there nice and tight now. It's not going anywhere. Look at it. So now it's got 2 controllers. My main controller and the baby controllers, which only one controller A is active, controller B is disabled. So controller A powering my front motor, and this 65 amp controller is powering the rear motor. Ready to go. Wiring had to be done to get it working. I was able to here, turnkey switch. The turnkey switch here is now connected to my 65 amp controller, not the baby controller. So it's connected directly to it, to power on, to switch on. And here, power is on. And controller, baby controller is connected to this, and it is bypassed without the turnkey switch. So I can switch on directly from here by pressing the power button. Turn it on, switch off to turn off the controller. This turns on the controller. So yep, this is temporary setup, like I said, just to get me going for more power. Now my scooter has a lot more power. It's got 100 amp theoretically. Rear motor is putting out 65 amp from the controller. Front motor is 35 amp from the baby controller. Rear wheel drive biased. Sports scooter. And the wiring had to be done in such a way to get this working, to get it arranged this way. It was a little tricky. I'm not an electrician. I don't have a background in working on electricity stuff, electric components. I don't have experience. I never worked as an electrician for electronic, for electric, devices like for homes and commercial buildings, working on power lines and switches and stuff like that, wirings. I don't have any of that experience. And I don't have an electrical engineering degree. I don't even have that. I was able to do it, although I have some experience with computers in the past for building my own computer and making modifications and to make the system run faster and all that, tweaking and stuff. But still, when it comes to actual wiring and understanding wiring and management for electric scooter is a different thing. I wouldn't be able to do it without God's help. Jesus is the one that has been helping me, guiding me every step of the way. Especially with the wiring. In order for the turnkey switch and the throttle display to work in such a way for this particular setup. And this is the setup that he wanted me to go for now. All this was planned, intended, and he has been guiding me. He has been showing me what wires to connect and what not. I simply obeyed him. He has been guiding me. Without his help, I wouldn't be able to do it. I would have to do studying. I would have to do a lot of research. I would have to get help, assistance from other people who have experience in modifying electric scooters. But no, I got help from God, from Jesus. So it is working. I made few changes to my electric scooter, as you can see. I removed the kickstand that was on here. It was useless. The way they positioned from the manufacturer, it was awkward position, where when you use it, the scooter doesn't tilt this side. It's almost sits straight up. So it's easy to knock over to the other side because there's nothing supporting it. It's useless. And I mean, I can drill a hole, reposition it to raise up the kickstand, but I don't want to do that. I don't want to keep drilling holes, and I don't really need it. So I removed it. As you see, I removed the deck light on both sides. I also removed the deck acrylic plastic cover on top. I don't need that. All those are extra weight. I did that for weight saving and simplicity. Especially the weight saving. Those things are heavy. The headlights, by default, they were further spread apart. Like they were over here, where the tube ends. Like here. I didn't like it. I wanted to bring them together closer. There was a horn in the way, in the center. So I removed the horn, brought these two together closer. I worked on the bracket to make it work. Horn is over here now. It's in better position now, way up here. This is a 60-volt horn from the factory. I was impressed. It's very loud. So I installed it up here. I will be getting a handlebar stand, 9 centimeters long. It will be like this long, and it will be pointing down a little bit. I want the handlebar to be low as I can get it go, because it gives me better balance for my riding position, for better control, aerodynamics, everything. And I will be able to stretch my arms better with a longer handlebar stem. This is too short. There's not enough reach, distance. It's a little too short. So I'll be doing that. And I have other plans coming. Jesus has plans, schedules for me, what I will be doing later. I will cover that later when the time comes. But for now, this is my setup, my temporary setup, just to get me going, because my previous setup from the factory was just too slow, not enough power. This should give me good power now. I haven't ridden it yet. I'm gonna go test ride it to see how it rides, how it performs. Look at that light. Look at that tail light. See? Turn signal. That thing is better. You can, the drivers can see better with that. Instead of just blinking. It actually show you the movement, left to right. Much better. Alright guys. I have a little bit of bad news. Well, to me it's a bad news. It may not be for others. For common people, for the general public. But for me, for the speed junkie like me, it's a little bit of disappointment. I just got back from my test ride, riding my scooter with this upgraded, beefed up controller upgrade. I pushed it. I tried speed 2 and speed 3 settings to see how much it can put out, how fast it can go. It's only about 4 to 5 miles per hour improvement compared to before. Compared to when the setup I had, the factory setup I had, maybe 4 to 5 miles per hour faster on the top end. That's a disappointment. It went up to 44 miles per hour. It's closer to GPS speed, only off by 2 miles per hour because I calibrated it. This display has better reading than this one here. I have already gone through settings to make sure that it is at optimal best performance settings. There's nothing else. The motor is more than capable. It's got plenty of headroom. And I know I have plenty of power. I have controllers that are able to handle the power. Turned out the only bottleneck that I see here is the battery. The battery is the limiting factor. At least it's not shutting down on me. That's a good thing. That's a good news. What's happening is that the battery is giving out what it can, all it's got, and my controllers are taking whatever the battery is offering in reality. Instead of, there's no safety switch or there's no sensor that detects like under power from the battery to shut down the battery and the controller. It doesn't have that. It doesn't do that. So that's a good thing. It's more trouble free. Instead, it just ran whatever the power it received from the battery. So that's good to know. The battery is underpowered. I was a little suspicious because when I looked at the battery, when I opened up the deck to see the size of the battery, the width, especially the width and the length, especially the width of the battery wasn't big enough, and that kind of bothered me, worried me, because that determines amperage, your output discharge amperage, and amp hours. And going this way, the length going this way gives you more volts, 52 volts, 60 volts, 72 volts, and so on. And also depends on the size of the battery too, and the amperage that each battery has. But that bothered me, the battery being not wide enough. So I had a bad feeling that it might not have enough amperage. It might not have enough amp discharge to give juice to the controllers to power the motors to go fast. It's the battery's limit. And it whether I that was with the dual motors running, both controllers running. I gave full throttle, both of them, and that gave me 44 miles per hour. I tried with just this itself, just get it off the big controller. That gave me 43 miles per hour. It shrunk by like 1 to 2 miles per hour. And obviously this can't handle it. This only goes to like 39, 40 miles per hour if you're lucky. If you have no headwind. If you have a tailwind, you can get to 40 miles per hour with this baby controller. Under bad weather, probably about 37 miles per hour. 36 to 37. So yeah, but the good thing is it gave me torque, a lot more torque than before. Well, a lot more torque than running off the baby controller in front drive. So that's obvious. I mean, you have two motors, so it's going to give you immediate power, torque, down low torque. So that was a good thing. It also gave me good torque, good pull, even in the mid-range. It was very smooth. It had a smooth power curve. I was actually pretty impressed with that. It behaves almost like a car. You can compete with the cars on the street. Under normal acceleration, you can outrun them pretty easily. So that's still pretty fast. I mean, for general public's perspective view, it's insanely fast. But for speed junkies like me, it's not so good. My previous scooter had way more power. It turned out that my previous scooter, even though it had Chinese batteries, it had a lot of amperage. It had a lot of current output from the battery. Even though it was unreliable, it had power. Because even just running with my previous scooter, just running off this controller in the rear motor, gave me a higher top end, faster top speed to 49 miles per hour, 49 to 50 miles per hour. Just with that alone, on that scooter. So this is about 5 miles per hour slower. It's battery's limit, guys. I guess that's why Jesus is already had it arranged. He already forecasted that I will be building a battery. He specifically pointed that out, like last year. Not this month, not this week, not 2 months ago. Last year, he already had the battery picked out for me, and then he told me that I will be building my own battery. So it was already planned, arranged, scheduled. And that he says I will be building the battery myself, and that it will be more effective and more efficient than the batteries you buy from the stores. Because it will be better, especially on the arrangement, battery cell arrangement with interconnects, connecting the batteries together. The methods will be different than what other manufacturers out there operate. So, and it'll be cheaper. I'll be saving about 60% on the cost, about 50%. And that it will be super powerful. The battery itself will be putting out anywhere from 325 to 350 amp discharge. Okay, 350 amp. In comparison, this battery here, I'm suspecting that it's only putting out about maybe, I don't know, 60, 70 amp. About 60 amp. I have a bad feeling it's actually only putting out 60 amp. Maybe 70 amp. Nothing more. That's why I'm not getting much power out of this, even with this big controller. It feels nice though. I already impressed some drivers out there. Because my scooter was taking off like a car, like a freaking car, like a motorcycle. It was smooth and quiet and just silky. It was silky smooth. I like that pull. It's just not fast enough. Only if it had a better top end, it would have been great. I just want my 55 miles per hour back. My previous scooter did. My previous scooter did 55 miles per hour GPS. Not the fake imaginary speed. I'm talking GPS. 55 miles per hour. That thing was fast. That thing had dual 100 amp controllers and more powerful Chinese battery. That scooter just pretty much, became almost useless. It just started breaking on me one by one. Motors, the controller was faulty, causing other components to break. I had battery just die on me. At least I got Samsung batteries, so it's going to be stable and solid. Even though it's not putting out a lot of power, it's reliable. It's dependable. You can actually depend on it. You know, it's more fail-proof. Great for common individuals, general public, like moms and pops. Yep. All right, guys.